Hello dear students, this is grade 12 mathematics lesson on unit 4 application of derivative. On today's lesson, we focus on critical numbers and critical values. So after revising this lesson, you are expected to apply derivatives in determining critical numbers and critical values. Not only that, you are expected to determine absolute maximum and minimum values of function on a given closed interval. So now let's continue to the lesson. Okay, let C be in the domain of f if f derivative of C is equal to 0 or f has no derivative at C, then C is said to be a critical number of f. A function is given to determine the critical number. What you do is simply you need to determine the point where the derivative of that function is 0 or the point where the derivative of that function does not exist. So let's see example for this. Consider the following graph and determine the critical numbers. Look this one. If we have this graph and have these different points, assume this point is A and this point is B and this point C and this point D and E. From these points, which one will be the critical numbers for this function f of x? Assume this function is f of x. To find the critical number, we need simply to find the point where the derivative of this function is 0. Derivative means it is a slope of tangent line. So we need to find the point where the slope of tangent line for this graph is 0. If you take tangent line at this point, it's a horizontal line. So the derivative at this point it is 0. So one of the critical number is b. So at this point f derivative of our function at b is 0 since the tangent line is horizontal. Not only at this point, you can see this point also. If you draw a tangent line at this point, you will have a horizontal tangent line. Therefore, the derivative of this function at this point is 0. So we have another critical number here also. This also is a critical number. So here f derivative of the function at C is 0. So C is also another critical number. If you see this point, it is a sharp point. So at this point, we can't draw a tangent line, a unique tangent line at this point. So the derivative of this function at this point does not exist. So this also another critical point, because the critical number also is found at a point where the derivative of the function does not exist. Therefore, at this point, the derivative of our function at D does not exist. Does not exist. Therefore, we have three critical points here. One critical point is B, the other one is C, and the other one is D. Therefore, x is equals to C, x is equal to B, and x is equal to D are critical numbers. These are critical numbers. Okay, now let's proceed to another example. Take this one. Find the critical number for this function. F of x is equal to 2x cubed minus 15x squared plus 24x plus 7. So to find the critical number, what we do is simply we need to find the derivative of this function, and then we seek the point where the derivative is 0 or the derivative does not exist, and that number also must be in the domain of the function. Now let's see the solution. So let's find the derivative of this expression. The derivative of our function f of x, this is equal to, the derivative of this one is, it is 3 times 2, it is 6x squared. And the derivative of this one, 2 times minus 15 is this minus 30x. And the derivative of this number is this, that is 24. And the derivative of 7 is 0, therefore this is a derivative. So the derivative of our function is 0, implies that this expression is 0. Therefore here 6x squared minus 30x plus 24 is equal to 0. And then divide this by 6, you get x squared minus this one is, it is minus 5 minus 5x. You divide 24 by 6, you get this 4 is equal to 0. So this implies, factoring this, you get this one is x minus 1 times x minus 4, this is equal to 0. So the derivative of our function will be 0 at x equals to 1 or at x equals to 4. So since the derivative of our function is 0 at these 2 points, these points are in the domain of our function, so the critical numbers are 1 and 4. Therefore, the critical numbers are x is equal to 1 or x is equal to 4. This is it. Okay, the third example here says find the critical numbers for f of x is equal to 1 minus x minus 1 the power of 2 over 3. So let's find the critical numbers. To find the critical numbers, simply we differentiate this expression. Solution. F derivative of x, this is equal to, the derivative of 1 is, it is 0. The derivative of this expression, since it is power function, this is equal to, it is, there is negative there, so minus 2 over 3 into x minus 1, the power of 2 over 3 minus 1 is this negative 1 over 3. Negative 1 over 3. So this implies negative 2 over 3 times, this can be written in this form, 1 over x minus 1 the power of 1 over 3. So from this, the derivative of this expression cannot be 0. So the derivative, this one, if you get 2 over 3 x minus 1 the power of 1 over 3 is equals to 0. Cross multiplication, you get that is equal to 0. So there is no number that makes this expression 0. But the derivative of this expression, it does not exist at x is equals to 1. If you put 1 here, this expression, it doesn't exist. And 1 is in the domain of our function. Therefore 1 is the critical number for this. Here, since at x equals to 1, f derivative of x doesn't exist. And 1 is in the domain of our function. Therefore, this x is equals to 1 is the critical number. It is the critical number of this expression. Okay, now let's proceed to the next part. Now example 4, here says find the critical numbers for f of x is equal to 1 over 3 x cubed minus absolute value of 4x minus 1. Now let's see the solution for this. Solution. So here f of x is equal to this expression can be written in other form. Since absolute value of x, we can define here absolute value of 4x minus 1 is itself. It is 4x minus 1 for x greater than or equal to 1 over 4. And absolute value of 4x minus 1 is, it is negative of this 4x minus 1 for x less than 1 over 4. So using this concept, we can rewrite this in this form. F of x is equal to, our function is this, a piecewise function. It is 1 over 3 x cubed minus absolute value of 4x minus 1, it is itself for this interval. 4x minus this 4x minus 1 for x greater than or equal to this, for x greater than or equal to 1 over 4. And for the other interval, it will be this 1 over 3 x cubed minus for x less than 1 over 4, the absolute value of 4x minus 1 is this negative of 4x minus 1. So you put the negative of 4x minus 1 here, this becomes plus. This becomes plus this 4x minus 1 for x less than 1 over 4. Now let's find the derivative of this expression. Let me simplify this first. It is f of x, our function f of x, this equal to this 1 over 3 x cubed minus 4x, and multiply this, you get plus 1 for x greater than or equal to 1 over 4. And this 1 is this 1 over 3 x cubed, 1 over 3 x cubed plus 4x minus 1 for x less than 1 over 4. So this is it. Now let's find the derivative of this. The derivative of this. The derivative of our function f of x, this equal to, it is this equal to the derivative of this one for x greater than part, greater than 1 over 4 part, will be this. You want to differentiate this one, 3 cancel 3, and x squared, this it is minus 4. The derivative is x squared minus 4 for x greater than 1 over 4. We are not sure about 1 over 4. We have to check the right side and the left side. So, and let's find for x less than 1 over 4 too. So the derivative for x less than 1 over 4 will be this. That is x squared plus 4 for x less than 1 over 4. Okay. For x equal to 1 over 4, we need to check the right side and the left side derivative. The right side derivative, or the derivative of this function from the right side of 1 over 4, is this 1, and the derivative of our function f of x from the left of 1 over 4 is this one. These two are not equal at 1 over 4. Therefore, the derivative of this function does not exist at x equals to 1 over 4. So it does not exist at this point. The derivative does not exist at x equals to 1 over 4. So from this, we have one critical number, 1 over 4, since the derivative of this function does not exist at x equals to 1 over 4. So we'll try to find also the other critical number. One critical number is this, x equals to this 1 over 4. 1 over 4. To determine the other critical number, we need to check the derivative of this function, where the derivative of this function is 0. Look for this interval, for x greater than 1 over 4, for x greater than, for this interval, the derivative is this one. So, is there a point where the derivative of this function will be 0 on this interval? Let's check that. X minus 4 is equal to 0. So, from this, you can see that x equal to this plus or minus 2. But from this, negative 2 is not on this interval, so cannot take this. But 2 is on this interval, so the critical number which is found on this interval is only positive 2. Therefore, another critical number for this function is x is equal to 2. So these are the critical numbers. When you check this one, the derivative of our function x squared plus 4 is equal to 0 on the interval. This cannot be 0. So only the critical numbers for this function are x equals to 1 over 4 and x equals to 2. This is it. Okay, the next concept is absolute maximum and minimum values. Now, given a function f on the interval I